Somebody asked me once, why is the universe so big? And I thought, well, that's a funny kind of question. Because the first thing you have to ask yourself is, big compared to what? Big compared to you, big compared to your living room. I mean, what's the reference point here? And the more I turned it over, the more I realized that this question, which sounds almost childish when you first hear it, is actually one of the deepest questions you can possibly ask. It touches on things that physicists and philosophers have been wrestling with for a long time, and the really honest answer is that we don't entirely know. But what we do know is strange enough to make you stop whatever you're doing and just sit there for a while. So let me try to take you through it. And I warn you, we're going to end up somewhere unexpected. Now, the first thing is to get some kind of grip on what we mean by big. Because the word big just completely fails us here. It fails us in a spectacular way. The distance from here to the sun is about 93 million miles, which already sounds like a lot, and it is. I mean, if you tried to drive it in a car going highway speed, you'd be driving for about 170 years. But that distance, that enormous, already incomprehensible distance, is basically nothing on the scale of the universe. It's a rounding error. The nearest star to our sun is about 25 trillion miles away. Our galaxy, just our one galaxy, is roughly 100,000 light years across. And a light year is the distance light travels in a year. And light moves at about 6 trillion miles per year. So 100,000 light years is, well, the number becomes meaningless. You can write it down, but it doesn't land anywhere in your brain because your brain did not evolve to feel numbers that large. And then there are, as best as we can measure, something like 2 trillion galaxies in the observable universe. 2 trillion. I remember once I was trying to explain very large numbers to a group of students, and I said, look, if you took a grain of sand, just one ordinary grain of sand from a beach, and that grain of sand represented our entire solar system, the whole thing, the sun, all the planets, everything, then the Milky Way galaxy would be about the size of North America. That's our galaxy, and the observable universe would be larger than the Earth itself. That's how many grains of sand, how many solar systems we're talking about in just the part of the universe we can see. And here's the thing that I want you to hold on to, because this is where it gets genuinely curious. That's just the observable universe, the part we can see. There's a limit to how far we can look, because light takes time to travel, and the universe has only been around for about 13.8 billion years. So we can only see the light that has had time to reach us. What's beyond that, we cannot see. And the current best models suggest the actual universe, the whole thing, is enormously, almost insultingly larger than the part we can observe. Some estimates say it might be 100 times larger. Some say much, much more than that. Some say it might be infinite. Infinite. I mean, what do you do with that? So, why is it this big? Why not smaller? Why not, a cozy little universe just big enough to have one galaxy, one star, one planet with some people on it who could look up and appreciate it? Why all this extra? Well, here's where I have to tell you something that I find absolutely remarkable. And this is the part that people don't always know. It turns out that the size of the universe and the age of the universe are not two separate facts. They're the same fact stated two different ways. Because the universe is expanding. It has been expanding since the very beginning, since that first unimaginably hot and dense moment we call the Big Bang. Everything has been spreading apart, getting farther from everything else. So the reason the universe is so enormously large is simply that it has been around for so long. It has had 13.8 billion years to expand. The size is a record of the time. You're not just looking at space when you look up at the night sky. You're looking at history. You're looking at time, stretched out in every direction. Now, I want to tell you something about that, because I think it's one of the most beautiful ideas in all of physics, and most people walk right past it without stopping. When you look at the night sky, you are not seeing the universe as it is now. You are seeing it as it was. The light from the moon left about a second ago. The light from the sun left about 8 minutes ago. The light from the nearest star left about 4 years ago. And when you look at, say, the Andromeda galaxy, which you can actually see with your naked eye on a clear night, a faint little smudge up there, that light left 2.5 million years ago. Before humans existed, Homo sapiens was not yet a thing when that light began its journey toward your eye. And the most distant galaxies we can see with our best telescopes, the light from those left over 13 billion years ago, when the universe was very young. You are looking at baby photographs of the cosmos. I find that completely, utterly astonishing. You are doing time travel every time you look up, without a machine, without any effort at all, just by opening your eyes on a clear night. Now back to the question, why so big? I started to answer it, and I said it's old, and because it's old, it's expanded to be enormous. But that just pushes the question back, right? Because then you ask, why has it been around so long? Why did it start with the particular properties that allowed it to expand at the rate it did, with the right amount of matter and energy and the right fundamental constants, so that galaxies could form and stars could ignite and planets could cool and life could eventually show up? And here, I have to be honest with you in a way that I find almost uncomfortable to say, because I don't like admitting the limits of what we know. But I think it's important. We don't fully know. There are ideas. This is what some people call the anthropic principle, which is really just the observation that if the universe were significantly different, if the constants of nature were slightly different, the gravitational constant, the strength of electromagnetism, the mass of an electron, you change any of these by even a little bit, and you don't get stars, you don't get chemistry, you don't get life, you don't get anybody around to ask why the universe is so big. So in a sense, we can only exist in a universe that is capable of producing us, which means we're necessarily going to find ourselves in a universe with these particular properties. It's a bit like asking why you were born in a hospital rather than in the middle of the ocean. Well, because if you'd been born in the middle of the ocean, you wouldn't be here to ask. But I want to be careful here, because that argument, while interesting, doesn't really feel like a full answer to me. It tells you why we observe these conditions. It doesn't tell you why these conditions exist at all. It doesn't tell you why there's something rather than nothing. Why any universe at all, rather than just a blank? And that question, why is there something rather than nothing, why does anything exist? I cannot answer that. Nobody can. That is the wall. That is where all the best minds in physics and philosophy eventually arrive and stand there looking at it. I used to think about this when I was lying awake at night, and I noticed something funny. The question, why is the universe so big, eventually becomes the question, why does the universe exist? And that question, when you really look at it directly, makes your brain do something strange. It sort of loops. You can't get outside it. You can't ask what was before the beginning, because time itself started at the beginning. You can't ask what's outside the universe, because space itself is part of the universe. Every question you ask from inside the system bounces back. It's a kind of curious trap, and I mean curious in the best possible sense. What I can tell you is this. You live in a universe that is somewhere around 93 billion light years across in the part we can see that has been running for nearly 14 billion years, that contains 2 trillion galaxies, each with hundreds of billions of stars, and somewhere in all of that, on a small rocky planet orbiting a pretty ordinary star on the outer edge of one spiral galaxy, a collection of atoms arranged itself into something that could look up and wonder about the whole thing. The universe made something that could be curious about the universe. Now, whether that's a coincidence, whether it was somehow inevitable, whether it means something, I don't know. I really don't know. And I've found over the years that sitting comfortably with that not knowing, rather than rushing to fill it with a quick answer, is actually one of the more honest and interesting places you can be. Why is the universe so big? It's been at it for a long time. Why has it been at it for so long? Well, now you're asking the right question. And I haven't got a clean answer for you, but I'll tell you, I think it's wonderful that we can ask it at all.